All right. Good morning again, everybody. So, happy Friday, last day of the week. So, kailangan nating tingnan kung gaano kahaba yung matatapos natin today. So, I can write laboratory exercise para sa Monday. Just a quick reminder, Lab Exer 1.2 is due on Monday, right before midnight. And you will have another exercise. Probably I'll upload it later today, which will be about whatever we'll finish ngayon with respect to Module 3. I expect it would be until the use of Chebyshev polynomials in polynomial interpolation. So siguro medyo iklian ko lang kasi I know dalawa yung gagawin nyo. So probably, so hopefully, nagawa nyo na yung Lab Exer 1.2 para yung Lab Exer 2.1 na lang yung gagawin nyo over the weekend or on Monday. Okay? So also, we just received an email from the Vice Chancellor. I think it was early last Wednesday, kaya hindi ko na kayo natanong ano. So we were told that we have the option to shift to face-to-face classes right after the reading break. I know we advertised the course as an M1 T1. Ano ba yung basta M1? So which is purely online classes. But if all of us will agree, we can have face-to-face classes instead, subject to several restrictions. Ano? Unang restriction ay may makukuha ba tayong room sa math building? An inventory of the rooms says hindi kakayanin na face-to-face lahat ng klase kasi parang more than 15 classes ang nasa time period na 8:30 to 10. So kasali tayo doon, 6 lamang ang classroom sa math building. So we cannot be accommodated there. And also, I don't know if we can open the lab classes face-to-face kasi yung mga computers na nabili way back 2016 na ginagamit sa lab, mukhang hindi na sila gumagana. So, but titingnan ko kung makakahanap tayo ng laboratory elsewhere, but I'm not sure. So yun yung mga restrictions, but nevertheless, I want to hear from you first whether you want to go face-to-face right after the reading break, okay? So pero yun nga, disclaimer, kung lahat kayo ay papayag, pwede natin gawin, pero kailangan ko pa maghanap ng classroom and ganun din para sa laboratory classes, okay? So probably I'll send out a Google form probably later today kasama ng laboratory exercise to gauge your opinion. Pero eto, dahil M1 yung in-advertise sa SAIS, tutuloy lang tayo sa face-to-face kung lahat kayo ay mag-agree. Okay? At kung may mahanap na classroom. If at least one of you will say, sir, hindi po ako pwede mag-face-to-face, then we will continue with the online mode. And based on student feedback last semester, or actually this past 2 semesters, mukhang okay naman yung 174 and 175 in a online delivery. Of course, assuming that you have good internet connection, meron daw magandang internet connection. So I don't personally I don't really see the need to shift to face-to-face. Ano? Kasi yung delivery naman ng 174, 175 is basically the same. Gagawin lang natin to ng harapan kapag ginawa nating face-to-face. I don't think there's much to change. Yun lang, yung access lang to the class because kailangan natin ng internet sa online, ng stable internet para sa online classes. Ano? But nevertheless, that's the state of things right now. Okay. So I hope to get your feedback on that. So today, tutuloy natin yung module number 3. Actually, sana matapos natin yung kalahati. And now we are looking at the use of Chebyshev polynomials in polynomial interpolation. Chebyshev. Hold on, nakalimutan ko ang spelling ng Chebyshev. Okay, why? Chebyshev. So Chebyshev polynomials. Because last time we were talking about how can we improve polynomial interpolation kasi nga ganun na. Nakapag-devise tayo ng isang paraan para makakuha ng isang polynomial na daraan sa isang bunch of points. And we said, alam na rin natin yung error term para sa kanya. Ang tanong natin ngayon ay paano natin mapapababa yung error? how can we optimize the approximation process? Now, we have identified last time several ways to do it. First, increase the number of points, pero nag-spoiler na ako, magkakaproblema pag basta-basta lang natin pinarami yung number of points. And you have seen this in laboratory exercise 1.1. Now, you might think of a counterintuitive phenomenon kasi number one, kapag ka dumarami yung points, dapat gumaganda yung approximation kasi mas maraming dapat daanan yung ating polynomial. So that means the polynomial will agree in more points when we use more interpolatory abscissas. So dapat gumaganda yung approximation, pero dun sa lab exer nyo ng stock prices, hindi ganun yung nangyari. There is something going on with polynomials kapag ka dumarami yung points na ginagamit, and we will address it in module number 4. Now, the second question is, ano pa yung pwede natin gawin? Well, if we have the option to choose the abscissas, then baka naman merong optimal way ng pagpili ng mga abscissas. At ito sana yung nakita niyo sa laboratory exercise 1.2 na pwede kong piliin yung mga abscissas, hindi lang sila equally spaced points, hindi lang sila mga random points, pero I can choose them in such a way that the error will be minimized. And yun yung tinitingnan natin in module number 3. Okay, so una, in this first section, we're talking about how to minimize the L infinity norm of the error, okay, by choosing the abscissas. At sabi natin ang paraan to do that is to look at Chebyshev polynomials. Well, Chebyshev polynomials are polynomials defined on the interval 0 to 1 that are defined as follows. So ito ay t sub n of x. So this is the degree n Chebyshev polynomial. This is cosine ng n r cosine of x. Okay. So provided that x is in the interval -1 to 1, hindi pala 0 to 1. It should be on the interval -1 to 1 kasi si x papasok muna sa r cosine. So that requires x to be a number whose absolute value is less than 1. And then saka pa siya mamumultiply by n, which is the degree of the Chebyshev polynomial, then it will be inside the cosine function. Okay, so that means the Chebyshev polynomials or Chebyshev polynomials will be bounded by -1 and 1 kasi nasa loob sila ng cosine, so hindi lalampas ng 1 saka -1 yung value ng t sub n of x. All right, and then we call them polynomials even though their domain are not the interval, is not the set of real numbers, but just the interval -1 to 1. Okay, so yun yung unang kaibahan ng Chebyshev polynomials. And then, bakit siya tinawag na polynomials? Cosine naman yung definition niya. We have seen last time the recursive formula for t sub n, right? So if you want to get the n+1 or the degree n+1 Chebyshev polynomial, all you need to do is do 2x times the degree n Chebyshev polynomial minus the Chebyshev polynomial 2 steps back, right? So ito yung recursion formula, and if you use this, you will see that t sub 0 of x is just the constant 1, t1 of x is x, t2 of x is what? 2x squared minus 1, and so on. So talagang sila ay itsurang mga polynomials, kaya lang ang domain nga nila ay from -1 to 1 lamang. And I think we finished last time by discussing several properties of the Chebyshev polynomials. Ano? Kaya lang medyo na-stuck ako dun sa pagkuha ng maximum ba? Hindi, pagkuha ng zeros ng Chebyshev polynomial. Though thanks to your suggestions, na-prove na naman natin siya, but just to reiterate kasi madalian natin siyang ginawa last time, ano? So when we are looking for the zeros of the Chebyshev polynomial, so we are equating t sub n of x to 0. We're looking for the x's because later we'll see that the roots of the Chebyshev polynomials will play a very important role. Okay, so pagkuha ng zeros, okay, gagamitin ko hindi yung kanyang polynomial form kasi mas madaling i-prove ito using mas madaling isolve yung kanyang roots using the trigonometric definition. Okay? So, ganun yung nasa remark. Sa remark 3.1, minsan mas madaling i-prove using the polynomial form. Minsan mas madaling i-prove yung properties using the trigonometric form. So, it's up to you to decide which form is better. So, para sa pag-compute ng zeros, gagamitin ko yung trigonometric form. Okay, equal kay 0. So here I'm looking for angles whose cosine is 0. So that means the angle and r cosine of x should be what? Magiging equal ang r cosine, ang cosine kapag ka ikaw ay multiple ni pi, right? Ni pi over 2. So this should be j pi over 2, where j is an integer. Okay. Hindi pala integer, where j is an odd integer. All right. So j should be an odd integer, tama ba? Yes, para mag-zero yung cosine. And then we divide both sides by n, so we'll get r cosine of x equals j pi over 2n. Again, the restriction is j is an odd integer. However, this angle, j pi over 2n, is the result of taking the r cosine of the variable x. Okay? So ngayon, we need to recall that the inverse cosine function is restricted from 0 to pi. So ibig sabihin, etong angle na to dapat nagbe-belong lang siya sa 0 to pi. So instead of considering all j's that are odd integers, ma-restrict na tayo dun sa mga values ni j kung saan yung value ng j pi over 2n ay between 0 and pi na lamang. Okay? So that means x will be equal to the cosine of angles of the form, sulat na siguro natin ang 2j minus 1 para makuha ko na lahat ng odd integers. So ito yung odd form ni j. Tapos ito ay pi over 2n. Okay. Tapos j goes from where to where? Well, j will go from 1 to hanggang kay n. Hindi siya pwedeng maging n plus 1 kasi pag nag-n plus 1 ka, lalampas ka na doon sa, lalampas na ito sa 2n. So magiging more than pi na yung value ng angle na 2j minus 1 pi over 2n. Okay? So that's the reason why restricted tayo dito sa mga j values na to. Kasi outside of these j values, etong j pi over 2n o yung 2j minus 1 times pi over 2n ay lalampas na ng pi. Okay? So I hope that's clearer now. And nakuha natin yung maximum also. The maximum and the minimum of the Chebyshev polynomials are 1 and -1. All right? Kasi nga, cosine lang naman yung definition, yung trigonometric definition ng Chebyshev. So hindi siya lalampas ng +1. Hindi rin siya lalampas ng -1. And the nice thing about it is madali ring isolve kung saan nangyayari yung absolute extrema. All you need to do is to replace 0 here by 1, trigonometric equation. So pag sinolve mo yung trigonometric equation na yun, you're gonna get cosine values of the form j pi over n, j going from 0 to n. Pwede na tayo mag-start sa 0 kay j doon kasi magiging cosine of 0 lang to within 0 to pi pa rin. Okay? Kaya take note, ito ay 1 to n, ito ay 0 to n. Okay? Another property of the Chebyshev polynomial na nakita natin last time of Chebyshev polynomials ay hindi sila monic kapag ka ang degree na nila ay mas malaki kay 1, meaning it will have a non-unit leading coefficient. So the first few Chebyshev polynomials, tingnan nyo itong T2, 2 na yung leading coefficient. Si T3, 4 na yung leading coefficient. Si T4, magiging 8 yung leading coefficient. In fact, the degree n Chebyshev polynomial will have leading coefficient 2 to the power n minus 1. For some reasons that will be clear later, I want my Chebyshev polynomial to be monic. So ang gagawin ko ngayon i-divide ko yung Chebyshev polynomials by a constant 2 to the power 1 minus n. I-divide ko siya ng 2 to the n minus 1 para maging monic na siya. All right. So all I'll do is define the monic Chebyshev polynomial as t sub n hat. All right. Siya ay equal kay t sub 0. Kapag kasi n ay 0, that's fine. Walang nagbago ron. Pero for degree 1 and higher, yung Chebyshev polynomial ay i-divide ko na ng 2 to the power n minus 1. Or i-multiply ko siya ng 2 to the power 1 minus n. Just to get rid of the leading coefficient. Gusto ko kasi maging monic yung polynomial na i-consider ko. Right, so for instance, ang t hat 0 natin ay equal pa rin kay 1. T hat of 1 ay equal kay 2 to the power 0 kasi magkakaroon tayo ng 2 to the 1 minus 1 times the Chebyshev polynomial of degree n. Si x lang naman to, so x pa rin siya, monic pa rin. Si t hat sub 2 of x, ito ay 2 to the power negative 1. Alright? Kasi ngayon ang n natin ay 2. Tapos ang t sub n, remember, is 2x squared minus 1. So ito ay magiging x squared minus 1/2. So basically, dinidivide ko lang yung Chebyshev polynomial by the leading coefficient, kaya na-force tayo na siya ay monic. So when we're talking about Chebyshev polynomials, monic siya kapag nilagyan ko siya ng hat. Okay? So what's the effect of anong epekto ng pagiging monic o pagpo-force na maging monic yung polynomial? Well, wala tong epekto dun sa zeros ng polynomial, right? Because if x is a zero of the Chebyshev polynomial, so halimbawa ang t sub n of x ay equal kay 0, then nag-multiply lang ako ng 2 to the power 1 minus n to both sides. Equal pa rin siya kay 0, so that means, and then this goes both ways. So this means that if x is a root of the Chebyshev polynomial, then it is also a root of the monic Chebyshev polynomial. So the fact that we made the polynomial monic, hindi na bago yung roots niya. Right? Kasi yung roots ng Chebyshev polynomial, siya pa rin yung roots ng monic Chebyshev polynomial. Medyo ang magkakaroon tayo ng change ay dun sa maximum value nung monic Chebyshev polynomial, right? So if I want to get, recall na lang muna, ang L infinity norm ng Chebyshev polynomial. Can anyone compute this for me? Ano ang L infinity norm ng T sub n? Ano ang supremum ng Chebyshev polynomials? Sige nga. Ano nga ang definition ng supremum o ng L infinity norm? Kalimutan nyo kagad. So remember, this is the supremum of the absolute value of t sub n of x over all values of x, so from -1 to 1. Yan yung definition ng L infinity norm. At ano to? For the case of the Chebyshev polynomials. Come on, guys. Yes, Christian.
Maximum po as of the absolute value of t sub n of x, where x equals to, where x is an element of -1 to 1. Tama po ba?
Yes, thank you, Christian. Yeah, that's the definition ng L infinity norm. Siya yung maximum, or in a more technical term, siya yung supremum ng absolute value ng t sub n of x, right? At ano yung magiging value niya kapag alam na natin si t sub n ay yung Chebyshev polynomial? Well, Ned and Dino got it on the chat. Tama, ang value niya ay 1 kasi ang t sub n ay cosine of something, right? And cosine of something will be between -1 and 1. So the highest value is 1. Yun nga yung kanyang absolute extremum, right? or absolute maximum, so 1 yung value nito. Okay. So kung 1 yung L infinity norm ng Chebyshev polynomial, ano na naman sa tingin nyo yung L infinity norm ng monic Chebyshev polynomial? Sige. Ano yung supremum ng monic Chebyshev polynomial? T sub n hat of x. Actually, wala dapat yung variable x pala dito. So, magsusulat na ng norm. Yung function name lang o yung function variable lang yung nasa loob nung norm bars. Okay. So ano kaya ang norm ng ano ang L infinity norm ng monic Chebyshev polynomial? Nicolate, that's correct. This is 2 to the power 1 minus n. Thank you. That's great. Bakit 2 to the power 1 minus n? Well, by definition, t hat is basically 2 to the 1 minus n times t sub n. So, siya yung papalit sa loob ng norm bar. Tapos, ito ay maximum ng 2 to the 1 minus n times t sub n. Pero alam natin, ang pinakamalaking value ni t sub n ay positive 1. I-multiply ko siya ng 2 to the 1 minus n, so matitira 2 to the 1 minus n. So the L infinity norm of the monic Chebyshev polynomial of degree n ay 2 to the power 1 minus n. And I think nakasulat siya dito. Right. Okay, kulay blue yung nandito. All right. Now, ito yung reason kung bakit pinag-uusapan natin yung Chebyshev polynomials. Iko-connect ko na siya ngayon sa polynomial interpolation. Well, Theorem 3.1 tells us that among the class of all monic polynomials of degree n, the monic Chebyshev polynomials attain the least norm. Okay. So, okay, yeah, sorry about that, Giancarlo. Start ako ng share. Yeah, sinabi mo sana ng mas maaga, so para hindi ka nahuli dun sa discussion. But it's okay. Yeah, whenever you join the class and you can't see the screen, just let me know para ma-start ko yung sharing. Okay. So, I hope this is okay, Giancarlo. Sa nakita mo na yung screen. I can't imagine kung gaano kahirap nang makikinig na wala ka nakikitang anything on the screen. Ang hirap, lalo na kung math yung subject, But anyway, going back, this is the reason why we were talking about Chebyshev polynomials. Kasi pag pinaghile-hilera ko pala lahat ng mga monic polynomials of degree n. So, sinulat ko sila lahat. There would be infinitely many of them. Pero yung monic Chebyshev polynomial, siya yung may pinakamaliit na L infinity norm. And siguro now it is clearer to you now kasi ano nga nangyari? Kasi gusto nating paliitin yung L infinity norm ng error term. Tapos eto nagkataon na si Chebyshev polynomials pala o yung monic Chebyshev polynomials pala yung may pinakamaliliit na L infinity norm among the classes of monic polynomials of a certain degree. Okay? Again, yung mga Chebyshev polynomials o yung mga monic Chebyshev polynomials, sila yung may pinakamaliit na L infinity norm among all monic polynomials of the same degree. Tapos, i-prove muna natin yung Theorem 3.1 and then let's see how we can take advantage of the theorem. But sana ngayon connect nyo na to dun sa objective natin na paliitin yung L infinity norm ng error. Kasi nga yung monic Chebyshev polynomial, yung may pinakamaliit na L infinity norm, so malamang dapat ito yung i-connect ko dun sa error term nung interpolation process. Okay? But before that, let's prove Theorem 3.1 first. So I'll do a classic proof by contradiction. Okay? So I will suppose, dahil ang sinasabi ng theorem, pag meron kang monic polynomial of degree n, sabihin natin na P, dapat mas malaki or equal, dapat yung L infinity norm ni P dun sa L infinity norm ng monic Chebyshev. Kasi sabi natin yung monic Chebyshev, siya yung may pinakamaliit na L infinity norm. Yun yung gusto kong ipakita. So classic proof of contradiction, I will suppose that there is a monic polynomial of degree n na mas maliit yung kanyang L infinity norm kesa sa L infinity norm ni T hat. Alright? So kunwari merong P na mas maliit ang L infinity norm kesa sa L infinity norm ni T hat. Sabi nga ni Nicolate, yung L infinity norm ng T hat ay equal kay 2 to the power 1 minus n. So in summary, I am supposing the existence of a polynomial P that is monic of degree n na mas maliit sa 2 to the power 1 minus n yung kanyang L infinity norm. Okay? Kasi ang gagawin ko, i-define ko si Q to be the function na T hat minus P. Okay? Now, tingnan natin si T hat minus P. I think I lost my screen share. Hold on, guys. Ano kaya nangyari? Okay. So, ano kaya yung degree ni Q? Kailangan ko i-take note yung degree ni Q. Again, Q is this guy. Yep. It's T hat, okay, minus P. Siya yung i-define ko to be Q. Pero ano kaya yung degree ni Q? Tinga, ano yung degree ni Q? Okay, thank you, Nicolate, again. Ang degree ni Q ay at most n minus 1. So it's degrees at most n minus 1. Bakit? Kasi si T hat, degree n. Si P, degree n then by assumption. Tapos parehas silang monic. So ibig sabihin, ang itsura nito ay x to the power n plus some other terms. Ito ang itsura niya ay x to the power n then plus some other terms. Kasi nga parehas silang monic of degree n. Tapos sinubtract ko sila sa mga cancel yung x to the power n. So at most, the degree of Q ay n minus 1 na lamang. Right? And this will play an important role later. Okay? Tapos tingnan natin ngayon kung ano yung relation ni Q doon sa T hat at saka kay P. Well, pag kinuha ko yung mga abscissas, yung mga minimizers at saka maximizers ni T hat, right? So si ZJ ay yung mga domain elements na ganito yung form, right? So alam natin na kapag ito yung mga CJs, alam ko na ang value ni T hat. So i-graph natin siguro dito. So Z1, Z2, Z3, Z4, or nag-start yata siya kay Z0. Balikan ko nga. Yes, nagsimula siya kay nagsimula siya kay 0. So sa J equals 0. So J equals 0, ang value ng Chebyshev ay positive 1. Kasi ito ay magiging 0. So this would be cosine 0. So that will be 1. Yun yung possible value. Yeah, that's gonna be 1. So ibig sabihin kay C sub 0, ang value ng Chebyshev polynomial ay 2 to the 1 minus n. So ito yung function value ni T hat sub n. Tapos at Z1, ang magiging value naman niya ay negative 2 to the power 1 minus n. Okay. Bakit nga ulit? Kasi yung mga CJs, sila yung mga abscissas sa remark 6. So sila yung mga domain elements na equal dito. Alam natin na sa mga Z's na to, alright, na-achieve ni Chebyshev polynomial yung kanyang maximum value na positive 1 at saka yung kanyang minimum value na negative 1. So pag itong mga to ay pinlogin ko kay T hat makukuha ko ay plus or minus 2 to the power 1 minus n. Tapos kapag ka si j ay even, makukuha ko ay positive 2 to the power 1 minus n. Tapos kapag ka si j ay odd, pag si j ay odd, ito ay magiging ang value ng Chebyshev polynomial ay magiging negative 1. So ang value ng monic Chebyshev polynomial ay magiging negative 2 to the power 1 minus n. Okay. So kaya mag-o-oscillate, yung function value nila, going back and forth kay positive 2 to the power 1 minus n hanggang kay negative 2 to the power 1 minus n. And this will happen hanggang kay c sub n. Alright? So ito yung mga values ng Chebyshev polynomial dito sa mga intervals na yan. Tapos ano yung assumption natin? Ang assumption natin ay si P ay may L infinity norm na mas maliit kesa kay 2 to the power 1 minus n. So that means the value of P over the interval negative 1 to 1, okay, value ni P over the interval negative 1 to 1 ay hindi lalampas ng 2 to the power 1 minus n. Right? So hindi siya lalampas ng 2 to the power 1 minus n. Dapat pala ito ay nasa negative 1 pa, no? So anyway, this is fine. Okay. Wala pala ito. 2 to the power 1 minus n. Kasi nga from negative 1 to 1 nga pala tayo. But essentially, yung values ni P, alright, ay hindi lalampas ng 2 to the power 1 minus n at hindi rin lalampas ng negative 2 to the power 1 minus n. Kasi kapag ka lumampas na yon, magiging mas malaki na yung L infinity norm niya kaysa kay T hat. So ibig sabihin, yung mga values ni P ay nandito lamang sa loob na yan. Alright? So siguro i-drawing ko rito. Ito yung mga possible values ni P. Ito yung possible values ni P. Hindi lalampas yung value ni P sa 2 to the power 1 minus n saka negative 2 to the power 1 minus n. Right? Tapos tingnan ko ano yung sign. Positive ba o negative si Q of zj sa bawat j na nandun sa theorem sa remark 6. Alright? So pag pinlagin ko halimbawa pag pinlagin ko si j equals 0, okay? Alam ko ang value nito ay positive 2 to the power 1 minus n. So makukuha ko yung maximum value ng Chebyshev polynomial minus the value of P. Okay? Ano yung value ni P sa CJ? Well, ang alam ko, yung value ni P sa CJ ay hindi lalampas ng 2 to the power 1 minus n. Alright? So that means Q of Z0 ay positive. Okay? Kasi nga mas malaki to kesa rito. So Q of C0 ay actually greater than or equal kay 0. Okay? Ganun din yung mangyayari kay Q of Z2. Pagka Q of Z2 nandito si T hat of Z2, ibig sabihin siya ay positive 2 to the power 1 minus n, minus P of Z2, pero ang P of Z2 hindi rin lalampas ng 2 to the 1 minus n. So 2 to the 1 minus n minus something smaller than it, so siya ay magiging positive pa rin. So in general, laging positive yung value ni Q kapag ka nasa odd tayo na C sub j's. So, ibig sabihin si Q ay posibleng nandito. Basta positive siya doon sa mga Z's na even yung subscript. So posibleng nandyan yung values ni Q. Right? So gamitin ko yung kulay blue para kay Q. And then I'll do this for also the odd C sub j's. So kapag ka si j ay odd, ibig sabihin ang value ni T hat ay negative 2 to the 1 minus n. Minus P sub Z sub j. Pero si P of C sub j ay hindi nga lumalampas ng 2 to the power 1 minus n. So ibig sabihin meron akong negative 2 to the power 1 minus n minus something that has absolute value smaller than that. So ibig sabihin hindi siya magiging positive. Kasi nga para maging positive yung value nito, dapat at least mas malaki kay 2 to the 1 minus n yung value nung isusubtract ko. Pero dahil hindi nga lumalampas ng 2 to the power 1 minus n yung value ni P, ibig sabihin laging negative yung value ni Q sa mga C sub J na odd yung J. Right? So that means yung Z sub 1, yung value ni Q sa C sub 1 ay nasa ilalim ng x-axis. Kay C sub 3, andito rin siya. Kay C sub 5, andito siya. Andito siya. Alright? So, ibig sabihin, nag-oscillate yung value ni QCJ from positive to being a negative number. Okay? Tapos ngayon, ang alam ko, si T hat ay continuous. Si P ay continuous din kasi ito ay degree n polynomial. So parehas silang continuous. So their difference must also be continuous. So ibig sabihin ng itsura ni Q ay parang ganito. Kasi nga continuous siya, so dapat may drawing ko siya without lifting my pen. Dahil continuous si Q, sabi ng intermediate value theorem, magkakaroon ka ng zeros sa pagitan ng dalawang x's na nagbigay sa'yo ng positive at saka negative value. So si Z0 ay si Q of C sub 0 ay positive, si Q of Z sub 1 ay negative. So by the intermediate value theorem, there exists a root between C sub 0 and C sub 1. So may isa na tayong root. Pero from C sub 1 until C sub 2, C sub 1 to C sub 2, nagbago yung function, nagbago yung sign ni Q. So ibig sabihin, meron na namang isang number sa pagitan ni Z1 at saka ni Z2 kung saan nagbigay ng isang root. So ibig sabihin, from C0 to Z2, meron na tayong dalawang roots. And then I'll do this gagawin ko ito ng paulit-ulit hanggang makarating ako kay C sub n. I will have a total of n roots. Kasi nga from Z0 to Z1 may isang root. From Z0 to Z2 meron dalawang roots. From Z0 to Z sub 3 may tatlong roots. So pag kinuha ko mula kay Z0 hanggang kay Z sub n, magkakaroon ako ng n roots. So ibig sabihin Q has n roots. Anong problema kung si Q ay may n roots? Sinabi natin kanina ang degree ni Q ay at most n minus 1. Tapos ngayon sinasabi natin si Q ay may n na roots. So that means sabi ng fundamental theorem of algebra, si Q dapat ay zero polynomial. Kasi sabi ng fundamental theorem of algebra, kapag meron kang polynomial of degree n, it will have at most n complex roots up to multiplicity. Pero ngayon, sigurado tayo, meron tayong n na iba't ibang roots para kay Q, pero si Q ay degree n minus 1 lamang, so ibig sabihin Q is the zero polynomial. It is zero everywhere. Okay? So dahil siya yung zero polynomial, pero si Q ay defined as T hat sub n of x minus P of x, dapat daw ito pala equal kay 0 for all x's in negative 1 to 1. So that means si T sub n hat of x ay equal kay P of x. So parehas lang pala sila, and this is a contradiction. Bakit naging contradiction yan? Kasi sinabi ko na si P ay may L infinity norm na mas maliit kaysa sa L infinity norm ni T hat. Yung pala, equal silang dalawa, so our supposition is false. So therefore, we cannot find a monic polynomial of degree n with an L infinity norm that is smaller than the L infinity norm of T hat. So ibig sabihin, totoo, na pag nilista natin lahat ng mga monic polynomials of degree n, kinumpute natin yung kanilang mga L infinity norm, ang may pinakamaliit na L infinity norm ay yung monic Chebyshev polynomials. Right? Is that good? Any questions? So sana ganito yung ginagawa nyo pag nagbabasa kayo ng proof. Pag nagbabasa kayo ng book, given yung proof, ina-analyze nyo line by line, or you're supplying missing details to the proof. So nag-notes kayo sa tabi ng proof kasi mahirap siyang basahin lamang. So maganda nagko-compute kayo on the side, you're doing some notes, you're rewriting some parts of it according to how you understood it. Okay, so para masanay kayo kung paano magsulat ng proofs. Okay? So sir, anong connect ngayon na alam na natin na yung monic Chebyshev polynomials yung may pinakamaliit na L-infinity norm. Paano ko siya magagamit sa interpolation? Well, remember, this is our goal. We want to minimize yung error, right? Yung L-infinity norm ng error, which is this guy. Gusto nating i-minimize to by choosing the exabytes wisely, right? But this error term is basically yung constant. Ilalabas ko lang lahat ng constants times the L-infinity norm of omega. Okay? Gusto ko ngayong palitin itong ang value nitong error term o ang L-infinity norm ng error term. So it boils down to minimizing, kasi constant multiplier to, it boils down to minimizing the L-infinity norm of omega. Alright? Pero ano nga bang itsura ni omega? Si omega ay ito lamang. So sulat ko lang ito ulit. Si omega ay product ng mga x minus exabytes as I going from 1 to n plus 1. So what can I say about omega? Si omega ay monic polynomial, right? Kasi product lang siya ng mga x minus a constant, x minus the abscissas. So pag multiply ko yon, magkakaroon lang ako ng leading coefficient na 1. Tapos ang degree niya ay n plus 1 because I have n plus 1 such factors. So basically, when you expand omega, it will look like x to the power n plus 1 plus some bunch of terms. Pero it's monic of degree n plus 1. Eh ano nga yung goal natin? Gusto kong mapaliit itong L-infinity norm na yan. Oh, ito ay monic. So, ibig sabihin, kailangan ko lang magawa na si omega dapat ay yung monic Chebyshev polynomial of degree n plus 1. Alright? Kasi nga, gusto nating palitin yung L-infinity norm na omega. Sino yung may pinakamaliit na L-infinity norm among the class of all monic polynomials? So, ang gusto ko ngayon mangyari, si omega ay maging equal doon sa monic Chebyshev polynomial of degree n plus 1. Alright? Ito yung gusto kong mangyari. Alright? So, gusto kong i-force yung issue na si omega na monic polynomial of degree n plus 1 ay magkaroon ng pinakamaliit na L-infinity norm na posible. So ngayon, pepwersahin ko yung issue. Dapat si omega maging equal doon sa monic Chebyshev polynomial of degree n plus 1. And if you have polynomials and you want to impose equality among them, all right? So ang madaling paraan to do this is to make their roots equal to each other because they are characterized by their roots. So ibig sabihin, ano ba ang roots ni omega? Ang roots ni omega ay yung mga interpolatory abscissas. Kasi nagiging 0 yung value ni omega kay x1, x2, x3 hanggang x sub n plus 1. Yung n plus 1 abscissas na ginagamit mo. Pero sino yung mga nagpapa-zeros kay Chebyshev polynomials? Ito yung cosine ng 2j minus 1 over 2n times pi, j going from 1 until n. Tama ba? Yan yung nagpapa-zero sa Chebyshev polynomials. Balikan ko lang. Ito yung mga nagpapa-zeros. Okay, good. So, ibig sabihin, para maging equal si omega doon kay monic Chebyshev polynomial and para maging equal sila, necessary na dapat parehas yung roots nila, right? Ang roots ni omega ay yung mga exabytes, yung mga interpolatory abscissas. Pero yung roots ni monic Chebyshev polynomial, ganito yung itsura. Eh gusto ko maging equal sila sa isa't isa. So ibig sabihin, dapat ang piliin natin ng mga x sub i's ay yung roots ng Chebyshev polynomial. So in summary, what we have shown here is that if we want to minimize the L-infinity norm of the error term in the interpolation, dapat ang piliin natin na interpolatory abscissas ay yung mga roots ng Chebyshev polynomial of degree n plus 1. Okay? So that pala to ay degree n plus 1. So, correction. Ito ay degree n plus 1 nga pala. No? So, hanggang kay n plus 1. Kasi si omega ay degree n plus 1. So, dapat kunin ko yung roots ng Chebyshev polynomial of degree n plus 1. So, dun sa formula sa remark 3.1, lahat ng n's papalitan ko ng n plus 1. So, basically, that's going to be our choice for the interpolatory abscissas. And if we do so, eto na yung magiging, at makukuha natin yung interpolating polynomial na may pinakamaliit na L infinity error. Okay? Does that make sense? I hope it does. And then, madali na ngayong computein. Ano yung minimum value nito? Right? So, ang minimum value niya ngayon ay n plus 1 derivative ni f evaluated at some unknown number c times n plus over n plus 1 factorial times L infinity norm ni omega. Pero sabi natin si omega pinipili ko na as t hat sub n plus 1. So ang L infinity norm na ngayon ni omega at ito na yung pinakamaliit na posibleng L infinity norm ng error term, ito ay equal na kay 2 to the power 1 minus n plus 1. Right? Kasi nga remember sabi niyo kanina ang L infinity norm ng t hat sub n ay 2 to the power 1 minus n. So ngayon degree n plus 1 na to. So this would be 2 to the power 1 minus quantity n plus 1, which basically reduces to 2 to the minus n. So ito na yung pinakamaliit na L infinity norm para dun sa error. And we can attain this minimum value if we will choose the abscissas to be the roots of the Chebyshev polynomial. Ang dami nating dinaanan, no? Dinaanan natin yung lahat ng theory para lang madiskubre na para mapaliit yung L infinity norm ng error, kailangan kong piliin yung mga exabytes to be the roots of the Chebyshev polynomial. Okay? And yeah, that's all that is to it. Okay? So tingnan lang natin mabilisan kasi 9:17 na yung mga examples. Okay? So I hope you can recreate these examples. Sabi rito, find the degree 10 interpolating polynomial for this function. So given yung function na gusto nating kopyahin o i-mimic yung behavior, so ibig sabihin, pwede tayo talagang mamili ng mga x's. Alright? So if you want to find the degree 10 interpolating polynomial for f of x equals arctangent of x minus e to the x plus 0.5 plus x plus 2, tapos sinabihan tayo to use Chebyshev notes. Okay. So ibig sabihin, ang gagawin ko lang dito, kukunin ko yung roots ng t hat 11. Alright, paano ko mahanap yung t hat 11? Kukunin ko muna yung degree 11 Chebyshev polynomial. Ito yung itsura niya. Tapos pag kinuha ko yung monic version niya, ito. So kukunin ko yung roots. Actually, parehas lang yung roots nito at saka nito as we remarked earlier. So it doesn't matter sino yung kukunan nyo ng roots. So kay MATLAB, pwede nyo ipakompute yung roots nito or yung roots nito. Or actually, pwedeng mag-shortcut kasi sinabi na ng remark 3.1.5 kung ano yung explicit na itsura ng mga roots. Sabi ng remark, ito lang yung itsura ng mga roots. So there are two ways on how you can compute the interpolatory abscissas. Compute the roots, ito yung long way, or gamitin na lang yung formula para dun sa mga roots. I heavily suggest you use this para mabawasan yung running time ng algorithm nyo. Right? Tapos sinabi tayo, find the degree 10 interpolating polynomial. So kailangan natin ng 11 Chebyshev nodes. Kaya ang kinuha ko rito ay yung roots ni T11 o kaya ni T hat 11. Para makakuha ko ng 11 abscissas, which are exactly the zeros of either of these two polynomials, which basically are equal to this. Tapos ayun lang, papakompute ko to kay MATLAB o dun sa programming language nyo para makuha yung 11 abscissas, and then yung 11 abscissas na yun din yung gagamitin nyo dun sa program na ginamit nyo sa LabXer 1.1. And if you do that, you'll get this polynomial. Tapos guaranteed tayo na ito na yung best polynomial for interpolating f, all right, with respect to the L infinity norm. So, pagka kinuha mo yung error, L infinity ng error, kinumpare mo sa kahit ano pang interpolating polynomial, right? When I say iba pang interpolating polynomial, ibig sabihin interpolating polynomial that you got by using a different set of abscissas. Kasi nga, yun lang yung paraan para magkaroon ka ng iba't ibang interpolating polynomial para sa isang function. Iba-ibang data points yung gagamitin mo. Kasi sabi ng unisolvence theorem, pag fixed yung data points, unique yung polynomial na makukuha mo. Pero pag iniba-iba mo na yung mga data points na ginagamit para ma-generate yung interpolating polynomial, magkakaroon ka na ng ibang polynomial. Alright? So pagka lahat ng posibleng interpolating polynomial of degree n para kay function f ay pinagtabi-tabi natin, tapos kinompute natin yung L infinity norm nung mga yon, laging may pinakamaliit na L infinity norm, eto si Q. Alright? So that's the advantage of selecting the abscissas to be the roots of the Chebyshev polynomial. Siya yung may pinakamaliit na L infinity norm. Okay? However, we cannot always do this, right? Kaya lang natin itong gawin kapag meron tayong freedom to choose the abscissas. Katulad nito, given yung function, so pwede tayo talagang pumili ng kahit anong x's para gamitin interpolatory abscissas kasi ipa-plug in ko lang si x dito sa function na to, makukuha ko na yung y value. Right? Pero hindi sa lahat ng pagkakataon pwede yon. Kasi halimbawa dun sa commodity problem natin, fixed lang yung mga excess dun sa ating data, so hindi natin siya ma-optimize using Chebyshev nodes. Alright? Any questions? Unfortunately, it's almost 2 minutes over time na. If you have a class right after this, you're free to go. Pero if you can stay with me for 5 more minutes, I'll appreciate it para matapos ko na yung part ng module, ng part A nitong module na to. And then if you got to go, then you'll just need to watch the recording later para mag-guide kayo dun sa susunod na exercise. Okay? Ano pa yung isang disadvantage nung paggamit ng Chebyshev nodes? Aside from hindi siya laging pwedeng gawin. Kasi nga baka limited lang yung data, wala tayong freedom to choose the abscissas. Ano pa yung isang, hindi naman disadvantage, ano yung isang restriction o isang limitation ng paggamit ng Chebyshev nodes? Anyone? Ano yung posibleng maging weakness, isa pang weakness nitong ating Chebyshev interpolation? Yes, ano yung restriction? Ano yung limitation nitong process na to? Parang ang ganda-ganda na ng promise niya, no? So, basta piliin mo lang yung exabytes to be the roots of the Chebyshev polynomial, makukuha mo na yung pinakamagandang interpolating polynomial with respect to the L infinity norm. Oh, great. Christian and Ray got it. Kasi nga yung mga roots ng Chebyshev polynomial ay naglalaro lamang from -1 to 1. Tapos sabi natin, valid lang yung interpolating polynomial between the smallest and the largest abscissa. So that means, kung gagamitin mo yung Chebyshev polynomials para makuha yung, para kunin yung abscissas, ibig sabihin yung makukuha mong interpolating polynomial is only valid from -1 to 1. Sir, paano kapag gusto kong mag-interpolate over the interval -30 to 30? Hindi na siya pwedeng gawin kasi using Chebyshev nodes kasi hindi na valid yung interpolating polynomial pag lumabas tayo nung interpolatory interval which is bounded below by the minimum value of the abscissas and above by the maximum abscissa. All right? So ang gagawin natin para ma-accommodate yung interpolation for x's beyond AB, gagamitin natin tong translation formula na ito. Okay? So kapag gusto mo mag-interpolate over the interval AB, pero gusto mong ma-minimize yung L infinity norm, and then kailangan nating medyo i-scale at i-translate yung Chebyshev nodes. Alright? O yung Chebyshev abscissas. Ito, kapag -1 to 1 lamang yung interval, ito lang yung gagamitin natin, the cosine factor here, right? Pero pag lampas ka na ng interval -1 to 1, say you have an arbitrary interval a, b, kailangan mo munang i-translate yung Chebyshev roots using this formula. So yung Chebyshev roots, kailangan mo siyang i-scale o i-multiply by half the length of the interval. So i-multiply mo siya ng b minus a over 2. Tapos ita-translate mo siya by a plus b over 2. So i-stretch na ngayon ng conversion formula na to, yung interval -1 to 1 papunta sa interval a comma b. This formula actually is derived by doing linear interpolation. So pwede nyo i-derive ito. Paano mo mapapahaba for yung -1 to 1 papunta sa interval AB. So ito yung gagamitin natin. So for instance, in example 3.3, you were asked to interpolate the function f over the interval -5 to 3. All right? So kailangan nyo munang i-translate yung Chebyshev nodes. So kukomputin nyo yung Chebyshev nodes kung ilan yung gamit. So dito ginamit ko ulit yung 11 roots. Dun sa example 3.1, yung cosine lang na ganito yung itsura yung ginamit ko para makuha yung roots ng Chebyshev polynomials, right? So my interpolation there is valid from -1 to 1 lamang. Pero dahil ngayon gusto ko ng interpolatory interval ay -5 to 3, I will implement this scaling and translation of the Chebyshev nodes with b equals 3 and a equals -5. And then ito na yung makukuha kong bagong interpolatory abscissas. And you will see that this roots basically are now representative of the interval -5 to 3. So yung roots ng T11, ito yung ginamit natin sa example 3.1. Pero dahil sa example 3.3, ang interpolatory interval na natin ay -5 to 3, gagamitin ko tong formula na to, and I will get 2.959 and change. All right? And then you will notice that these numbers are well distributed from -5 to 3. Tapos itong mga roots na to, ito yung gagamitin kong vector t dun sa program na ginawa natin for basic Lagrange interpolation. Wala tayong nabago rito dun sa interpolation process, namili lang tayo ng magagandang exabytes para ma-minimize yung L infinity norm. Okay? So try to write a program about this, okay? Tapos i-compare nyo with what polynomials I got in this module, all right? Tapos yung laboratory exercise 2.1 ay maglalaro dito sa Chebyshev interpolation. Okay? Or interpolation using Chebyshev nodes or a scaling thereof as interpolatory abscissas. Okay? So any questions? So siguro I'll try to have the lab exer uploaded mamayang gabi right before midnight. Although meron palang nagyayaya ng dinner meeting, so baka malate ako. So expect it by tomorrow 8 a.m. at the latest. All right? 8 a.m. tomorrow at the latest. Maiksi lang naman to, so okay lang na ibigay ko siya ng Saturday na, no? So, or I'll try to upload it right before midnight mamaya. Pero if not, 8 a.m. tomorrow, LabXer 2.1 will be up. Expect it to be an application of Chebyshev interpolation. Okay? So baka magbigay lang ako ng data tapos papa-interpolate ko lang. So basically, pwede nyo gawin within the day. If you're free, try to modify your program for Lagrange interpolation to accommodate the use of Chebyshev nodes and translations thereof. So program nyo lang yung pagko-compute ng Chebyshev, tapos program nyo rin yung pagta-translate ng roots ng Chebyshev kasi baka sakaling yung ipapa-interpolate ko sa inyo ay mas malaki yung interpolatory interval kaysa kay -1 to 1. All right? Any questions? Questions? Oh, yes, Nicolette.
Question lang po, sir. Di ba po kapag nag-translation na, bago na po yung magiging omega po. Bali, yung L infinity norm po nung omega po na after translation, same lang din po ba sa kapag yung...
Yeah, good question, Nicolette. Right. Actually, yan yung gusto kong i-discover nyo dun sa LabXer 2.1. one. So, hindi ko sasagutin. Ayokong spoil. Pero ang tinatanong niya ay, di ba sir, kapag ka Chebyshev nodes yung ginamit, Chebyshev nodes. Sure tayo na ang L infinity norm ni omega ay 2 to the power minus n. Kasi ito yung na-derive natin and so on. Okay? Pero ito ay nag-work kapag si omega ay x minus x sub i's, where the x sub i's are the roots of the Chebyshev polynomial. Ang tanong ni Nicolate ay, anong mangyayari sir kapag translated na yung mga x sub i's? Alam ba, tawagin natin silang x tilde i's. So yung x tilde, siya naman yung translated roots. Ano yung itsura ng L infinity norm ng omega? 2 to the power negative n pa rin ba? I will not tell. So, yun yung isa sa mga itatanong ko sa laboratory exercise nyo next meeting. Alright? So, yeah. Kasi pwede nyo tingnan. Pag binuo mo si omega using this x sub i's, makukuha yung maximum ng monic polynomial na yon ay 2 to the power negative n. Pero ano kaya mangyayari kapag kinuha nyo yung omega na manggagaling naman dito sa translated roots? Ano kaya yung kanyang maximum value? Right? And hopefully, kaya sayang sana na-discuss na natin yung exer 1.2 eh. Kasi yung exercise 1.2 will give you an idea how to get the maximum or the minimum of a function. Actually, at least to get an idea of the maximum or minimum of a function. So kailangan yung pag-isipan, paano nyo mahanap yung maximum ng isang polynomial function. Okay? Meron sigurong intrinsic na command si MATLAB para ma-maximize si omega. Kasi gusto nyo makuha yung maximum ng absolute value ni omega. Si omega ay polynomial lang, so I think MATLAB has a command for that para ibigay sa atin yung maximum ng absolute value ng isang polynomial. Or kung hindi man, pa-compute nyo yung maximum at saka yung minimum niya, tapos pag-compare nyo yung absolute value ng dalawa na yan para makuha yung L infinity norm ni omega. Or may isa pa kasing paraan, sige na nga, sasabihin ko na, ipag-graph nyo si omega. So pag napag-graph nyo si omega, makikita nyo na kung ano yung highest absolute value. So magkakaroon kayo ngayon ng idea, 2 to the power negative n pa ba yung L infinity norm pag tinranslate ko na yung norm? Kasi makikita mo yung graph noong translated omega, tapos makikita mo na 2 to the negative n pa rin ba yung maximum absolute value. Kung malayo na, then yeah, hindi na na-retain yung 2 to the minus n. Kung malapit pa rin sa 2 to the minus n, so that means probably invariant yung L infinity norm ni omega. Pero ang promise nito ay siya pa rin yung may pinakamaliit na L infinity norm. Okay? Among the class of interpolating polynomials. So yung translated roots ng Chebyshev polynomials, sila pa rin yung mga abscissas na magbibigay ng pinakamaliit na L infinity norm para sa error. Okay? Pero this time, doon na sa buong interval, negative 5 to 3. The question remains, is the L infinity norm of omega still 2 to the negative n? Yun yung malalaman natin sa exer 2.1. Okay? Anticipate ni Nicolate yung tatanong ko eh. So, yan. Any other questions? All right, so if there are none, thank you guys for waking up early today or extra early, 8:30 yung klase natin. Enjoy the rest of the day. Enjoy the weekend. Enjoy it by doing the laboratory exercises. But we'll see each other again on Wednesday. Okay? Bye, guys.